that we know how to work with negative exponents, let's see if we can make sense of negative exponents versus negative of the whole quantity. Remember, negative exponent does not make the quantity positive or negative. Negative exponent, you can think of the negative in the exponent as sort of like a placeholder. It's really just making the base move either to the numerator or denominator. So for example, how do I make sense of this example that's being worked out here? You can see that this negative actually is outside the parentheses. If you put imaginary parentheses here, imagine the parentheses. This 2 as an exponent simply belongs to that 3. So this 2 is a power of this 3, or 2 copies of 3, which is going to give you 9. And that's why you have the parentheses here, which gives you that negative sign. All right? So make sure that you keep track of the parentheses. So for example, here the parentheses are here. It's a little overlap here, but this negative sign is outside the parentheses. And so this 3 to the negative second, you're going to take care of first, because there's an exponent and here's the base. This negative 2 of an exponent means take the base to the denominator to a positive power. That's what this negative is doing. It has no bearing to this negative. Has nothing. No, nada. No effect. This negative 2 has nothing to do with that negative. You're simply taking this negative exponent and using the meaning of what we define negative exponent to be. We said that base to a negative exponent is 1 over base to a positive exponent. And we know how to evaluate 3 squared. It's going to be 3 times 3, or 9. And that negative sign is going to be a part of the answer because it's outside the brackets. Let's take a look here. Here the negative side is on the inside of the parentheses. So this power of 2 belongs to the entire negative 3. Negative 3 is your base. Remember when we were doing the exercises? Negative 3 is the base, 2 is the exponent. So negative 3 times negative 3 is going to be 9. Here we have the negative 3 again inside the parentheses. So this negative 2 is going to make it go to the denominator, and now you have 2 copies of negative 3 in the denominator. And you have the 2 copies of negative 3 in the denominator because of the exponent of negative 2. Everybody got it? Go back and rethink it and listen to the explanation if you're not quite getting it. What about this? Again, the negative is in the parentheses, so you have 3 copies of negative 2. 3 copies of negative 2, and so multiplying will give you negative 8. Here, the negative 3 power is moving the base, which is negative 2 is our base, positive exponent. So now you have 3 copies of negative 2 in the denominator. Do you see what the effect is of this negative exponent versus this negative sign that belongs to the number 2? Here we're saying you have 3 copies of negative 2, but the 3 copies of negative 2 are in the denominator, right? All right, let's look at the next example. So here the negative sign is again on the outside, and so you should really, I'm not putting the parentheses there, but you should think of the parentheses there. Same thing here. This negative 2 going to move the base to the numerator, make it a positive base. Again, imagine parentheses right there. I didn't put them there because eventually you want to get used to imagining the parentheses there and not having to put them down. Whereas in the previous examples, I put them there so you get used to it. So imagine a big parentheses here. So this 2 is saying I have 2 copies of 3 in the denominator. 3 to the negative 2. That negative 2 is moving the base of 3 to the exponent, to the numerator, and having the exponent become positive. Here we have negative 3 twice because in the denominator because it's a positive 2. Look at the difference between here and here. This negative 2 makes the 3 go to the numerator, and you have 2 copies of 3. There's a parenthesis here, remember. if you have trouble with this, you should always put the parentheses there. There's no harm in putting it there. But I wanted to get used to, if somebody didn't put the parentheses there, how you would interpret it. Now look at what happens here. The exponent is -2, so we have to move it to the numerator. The base moves to the numerator. Base is -3, exponent of 2. Here's another example. So we're doing all these examples so you understand the relationship between negative exponent and negative as a base, or negative of the quantity. So here the negative belongs to the quantity. Here the negative is for the base in the denominator. Here the negative is to the base in the denominator, which has a negative exponent, which takes this to the numerator. So do pause the video and make sense of this. If not, always go back to the class and ask your teacher. Here's the last example where you're going to end up with -2 is your base, but you also have a -3 as an exponent. So -3 exponent gives you the -2 base moving to the numerator, and now you have 3 copies of -2, which will give you -8. All right, so let's recall all the stuff that we've done so far. We first started with defining for a non-zero real number a and a counting number n, a to power n as being n copies of a. And then eventually we said it doesn't even have to be just a real number. A can be any mathematical object, and it will mean the same thing. And we said n would be the exponent and a would be the base. We then looked at different properties or observations of how to combine exponents and whether they are multiplication or division, as long as we had the same base. So if you have same base to a power times same base to another power, we saw you had n plus m copies of a. You had base to an exponent, m copies of that will give you n times m copies of a. Division, we said we could subtract exponents, and it was okay if we got negative exponents, because the way we made sense of them, we said if you have a base to a negative exponent on the numerator, you can say base to positive exponent in the denominator. If you have base to a negative exponent in the denominator, it would be base to the positive exponent in the numerator. All right, so now I want you to simplify these 6 problems for practice. Pause the video here, do the problems. Do please pause and do the problems, because the next set of questions is your video log. I'm going to provide the answers here and make sure you understand how I got the answers. I'm going to briefly explain to you. 4 to the negative second, which means 4 to the positive 2 power in the denominator. This negative, there is a parenthesis here. Remember we said imagine a parenthesis here, so you know how to evaluate. 2 to the -4 power will give 2 to the +4 power in the denominator. -3 to the -2 power. -3 is the base. +2 power in the denominator. A to the -5 will become 1 over a to the 5. 7 to the 3rd, 7 to the 14 will leave you 11 sevens in the denominator, because we were asked not to leave any negative exponents. And then -d to the 15 power, and -d to the -4 power is in the numerator, so it will go sit in the denominator, and then you can combine the two together. This is exactly how your video log questions are going to be. So go ahead and get paper, pencil ready, and be ready to do the video log questions. Again, they'll appear in a random fashion. So go ahead. And remember, you don't want to leave any negative exponents. If the problems flash too fast, pause the video and go back and get them all. Just rewrite with no negative exponents. Remember to pause the video when the question flashes too fast for you, so you can see the question and have time to solve it. All right, so here are some more video log questions that we would like you to do.